Well, welcome everybody. Thanks so much for coming along today. This is Dolby Australia's virtual tech talk. I've got Richard Cartwright, who is the Director for Speech Analytics at Dolby here in Sydney, and he's going to give you a very interesting technical talk, and then we'll have some Q&A afterwards. And then once we're finished that, I'll also wanted to talk to you a little bit about the Dolby University Internship Program as well. So I'll save that to the end. So Richard, when you're ready, take it away.
There we go. All righty. So hi everyone. What I wanted to share today was some of the thoughts, some of my thoughts around technology and challenges in audio AI. I'm quite happy to make this interactive. So if you have questions along the way, feel free to chime in and ask. You don't have to feel like you need to save them till the end, but that's also fine as well. So let's get started. There are really good reasons why we as humans communicate primarily using our voice. Our voice is efficient. You can communicate ideas really quickly and efficiently using your speech. Each voice is unique. Typically, people can understand exactly who's talking just by listening to the quality of your voice. They know who it is. You can use your voice while you're doing other things like driving a car. And lastly, your voice tells a lot more about you than just the words. So by listening to someone's speech, you can tell not only what they think, but also potentially how they feel about it and that sort of thing by listening to paralinguistic cues. And so it's not surprising that given that we humans talk to each other using our voice, that for quite some time now, humans have been dreaming about communicating with machines using their voice. Now, I might be showing my age here, but I grew up in the 80s. And when I was a kid in the 80s, I really enjoyed tuning in every Saturday night to watch David Hasselhoff talk to Kit in Knight Rider. And what I thought was really cool about that was the really frictionless and seamless communication that David was able to have with Kit in that show. And I don't have one of these yet. I don't have that experience. But what I do have is a smart speaker in my home. And today we find ourselves somewhere near the beginning of the age of voice as a primary UI to communicate with machines. It's become commonplace over the last few years for us all to talk to smart speakers, to smart watches, smartphones, to computers. And what I thought I'd do over the next half an hour is give you a bit of a glimpse into how this all works and what some of the challenges are in the area. Some of them might not be so obvious to you. And I want to talk about some of the opportunities I see to use things like cross-disciplinary thinking to improve performance of speech analytics technology. So I'm hoping that at some point in the next half hour, you might find something from my world that you can take and apply to yours. And so let me introduce myself briefly. I graduated from UNSW in 1997 in electrical engineering, and I spent the late 90s part of the team at Lake Technology here in Sydney. And the brief there was to try and democratize surround sound in headphones. So we had very large DSP workstations that were used in professional virtual reality setups in the late 1990s. And the mission was to get that to run on ordinary PCs of the day. And that meant a lot of porting to chips like the old 486, which is a very different kettle of fish to today's computers. That technology was later licensed to Dolby and became Dolby Headphone, part of Dolby Audio, and is on millions of PCs around the world today. In the 2000s, I was an independent digital signal processing consultant, and I worked for a range of companies in the US and Australia and other places. Here are some of the projects I worked on. So on the left-hand side is the Dolby Lake processor. This is the front of house speaker controller for large stadium gigs. If you've been to a large stadium gig anytime in the last 10 years or so, you would have heard the Dolby Lake processor or or technology derived from it, powering the front of house speakers. In the middle is one of the teleconferencing products that I worked on as a consultant, and on the right-hand side is Bootsy Collins, who's a bit of a funk legend, having played with James Brown and various people over the years. He's got a couple of the guitar pedals that I used to make. Since 2010, I've been with Dolby, and this is a picture of the Dolby conference phone, which is a product that came out of our Sydney operation here. This is a surround sound teleconferencing device. And for the last 5 years, I've been heading up the speech analytics team, looking at how speech analytics plays a role in our technologies at Dolby. And many people don't realize that Dolby Australia here is one of the key places in the world where Dolby does cutting edge research and development. We have about 150, is that right, Steve? About 150 folks at the moment?
Yep, that's right. Just over 150 people here in the Sydney office.
Yeah, so 150 people here in Sydney doing R&D. So there's almost, I think there's zero marketing or sales going on here in Sydney. It's all R&D. So that's me. What is this speech analytics thing that I'm talking about? Well, I'm talking about these kinds of technology. Speaker recognition, so that is working out who's talking. Speaker verification, so that is working out whether somebody is who they say they are from their voice print. Speaker diarization, so that's working out how many people there are and who's talking at any one time. Language recognition, so working out if it's French, German, Arabic, Chinese, whatever that we're listening to. Emotion recognition, how does someone feel? Are they stressed? Do they have even some kind of condition? We can sometimes tell some of those things from people's voice. Wake word detection, so is someone trying to wake up a virtual assistant by saying Alexa or OK Google or whatever the virtual assistant wake word is. And speech recognition, which is probably the sort of easiest to understand of all these tasks, which is trying to work out what someone is saying to a machine. So let's use speech recognition as an example and talk about how that works. So sound comes into a microphone, and we sample the sound pressure through the microphone with a digital to analog converter, typically about 16,000 times a second. Now, if you're trying to record something really high quality, you might go higher than that, but for speech recognition, about 16,000 times or 16 kilohertz sampling is fairly commonplace. So from those 16,000 numbers per second, we need to work out what the person is saying. So here's an example of someone saying something, it's me saying something at 16,000 samples per second.
Recognize speech.
And Steve, I trust that came through okay?
Yep, that came through.
Cool. So you don't typically run your analysis straight on your linear PCM or your 16,000 samples per second. What you'll typically do is reduce it to what's known as features. So here's an example of some features that we use for speech recognition. These are 25 mL-spaced bands, and we derive the band power in decibels in each of those 25 bands about 100 times a second or every 10 milliseconds. And that makes a picture called a spectrogram, which you can see here, and that's typically what you'll feed into your speech analytics system to work out what's being said or whatever it is you're trying to do. After that, you'll typically run it through something which is trying to extract higher level features like phones. So this can be called an acoustic model. And this is a typical output from an old school acoustic model using hidden Markov models and Gaussian mixture models. Of course, today's ones all use deep neural nets, but the previous generation used Gaussian mixture models. So in English, we have about 45 to 50 different phones, depending on how you count them, and whether you're talking about US English or British or Australian English, etc. And some phones sound really distinct from others. So phones like S, for example, the S sound is quite distinct. And so you can see there are times on this posteriogram, so this is the probability of each phone as estimated by our acoustic model, the first part of the speech recognition process, you can see there are times when it's quite sure which of the sounds is being uttered. And there are other times, like this area here, where it's really not very sure. And so that stands to reason when you start to listen to the way human speech sounds and how the phones sound. So if I pull out one chunk of this, one short chunk, and we listen to it repeated, let's see if you can hear what phone I'm saying here. And what you probably find is it's kind of a bit, it could be any phone. I mean, it's obviously some kind of vowel sound, but you can't really tell exactly which phone. And one of the key reasons why today's deep neural network-based speech recognizers do so much better than the previous generation is it's much easier to incorporate much more temporal context into a deep neural net-based speech recognizer. So if I now go and play a longer snippet, repeated, this is the kind of thing that a deep neural net today will be listening to in order to work out which phone is being uttered. So you can hear, by incorporating more context, it becomes immediately apparent that I'm saying something like I as opposed to something like So you can tell which of the vowel sounds I'm starting to say. So this has been one of the key advances. By having systems that can bring in more context, they're better able to do their job. So just to remind you, this is I from recognize speech.
Recognize speech.
That's the whole clip. So once I've recognized what phones are being uttered, the next step is to try and turn it into words. And that sounds relatively easy. I just get a lexicon of all the words and their pronunciation. So this is a snippet from one of the commonly used lexica. This is the Cmu Pronouncing Dictionary, or Cmu Dict, and it has about 133,000 US English words and their pronunciation. And it's pretty interesting looking at some of the words that you see here. These are not words that we would use in everyday conversation typically. Not sure if that was a question. I'm going to continue, but please interrupt if there's a question. But what you need to do if you want to recognize all the sounds in English is have, for example, all the names of places and all the people, which makes it kind of hard. So you see there's a lot of names and stuff in that lexicon. So what do? I've recognized phones by putting them through an acoustic model. I can turn that into words by putting them through a lexicon, potentially quite a large lexicon. Should be pretty easy, right? Well, it turns out it's not quite that easy because we humans use quite a lot of context to work out what each other say. So have a listen to this and see if you can tell me what I'm saying in this clip.
I need you to recognize speech.
Maybe let's get interactive. Who wants to tell me what I said in that clip? What about you, Steve? Want to have a guess?
Rani has typed it into the chat, which is, I need you to recognize speech.
Very good guess. In fact, this is me saying, I need you to recognize speech.
I need you to recognize speech.
And that was me saying, I need you to recognize speech. And now I've done a good job of priming you by playing me a recording of me saying, I need you to recognize speech multiple times. But it would be an extremely unusual thing for one human to say to another human, I need you to go recognize speech. And so we're using all of our high-level context as human beings to know that it's much more likely than I'm saying, I need you to recognize speech, amongst other things. And so just from that simple example, you can see that you're going to have to teach a computer a lot of human knowledge in order to get it to understand what we humans are saying. And so what you end up with is something like a graph of all of the possible words that might have been spoken during an utterance. And an example for that particular phrase might look something like this. And what's to stop you from choosing this set of examples for this set of words they sound very similar. So pie, mead, you, do, rec, alive, peach. I mean, taken in isolation, each word sounds very similar to its counterpart that was actually spoken. Also, what would be stopping you from choosing this set of words? These are all the correct sounds, and this is another issue, particularly with languages like English, where we have a lot of homophones, that is, words that sound the same that are written differently. You need to know the high-level context of the language to work out which of the ways you can write each sound is the appropriate one, so that you know that this is the correct orthography for the phrase that was spoken there. So how do you do that? Well, modern large vocabulary speech recognizers have a language model that models statistics of how words appear in the language. And a common way to train these is with something like Google's Ngram corpus, which is built by analyzing how frequently words occur after other words on the whole internet, because they're crawling the internet with their robots to build their search database, for example. And so this gives you quite a good idea statistically of what words are likely to follow other words on the internet, which might be slightly different to spoken speech, but it's one of the best ways we've got to do it. You can build from corpora like that weighted finite state transducer type models, and you can build recurrent neural network type models, which are the two most popular ways of modeling languages. And these models are quite large, and knowing how to prune them well is an art. And so you only do it when you have to recognize very, very large vocabularies. But not every speech recognition system needs a large vocabulary. So if you're writing a speech recognition system that needs to go into a garage door remote or a remote control for a television or something like that, you probably would choose a different way to model language. And a common way to deal with those is using a finite state automaton, which I'm sure you're familiar with from, I guess it's a first year computer science topic associated with regular expressions and so forth. And also context-free grammars, which you might learn about if you're designing compilers and things like that. So a very, very similar task is small vocabulary speech recognition, where you have a grammar that describes the acceptable sequence of tokens. So you can use that kind of thing for command and control. And then lastly, there are other types of speech recognition systems where the vocabulary is virtually infinite. And a good example is if you're trying to build a navigation system where you need to be able to say, or the system needs to be able to say back to you, the names of all of the street names in Australia, for example. It's unlikely you're going to have the perfect pronunciation written down for every street name in Australia, and some of them are kind of unusual, like Paran, for example. So how are you going to do that? Well, that is dealt with by a system known as G2P, which is grapheme to phoneme prediction, and that is where you train a model that takes a string of graphemes, that is the letters, and predicts what phonemes or sounds will be produced for each one of those letters from a large training corpus. So that's G2P. Okay, so we've spoken about a couple of different ways that you model words in the language. Where have we got
Richard,
to?
just quickly, sorry, pardon me.
Yeah,
we have a question around, can you asking what the first model was that you mentioned?
Oh yeah, so an Ngram model.
Yes.
An Ngram model where you know based on the previous number of words, 1, 2, 3, 4 words, what word is likely to come next. In fact, what the probability of each word coming next is. And you can model those using weighted finite state transducers or using RNNs.
Right, okay, thank you.
Sorry, I can't actually see the questions at the moment because I don't have the...
Well, I will interrupt if you don't mind.
Yes,
I'll moderate and I'll jump in when required.
Very good, thank you. All right, so we talked about language modeling. And so here's our complete speech recognition system. So we're taking audio in through our microphone array. We're doing feature extraction. Remember those band powers I showed you. You run through some kind of phone recognizer powered by an acoustic model. And then with your combination of your language model and your lexicon, you're able to resolve that into a sequence of words, and then you've got a transcript that comes out. Well, it turns out that's not the whole story. And in fact, that's really only half the equation. The other half of the equation is the signal processing that you've got to put on the front. So let's talk about what I mean by that. So I'm talking about these kinds of technologies. Noise suppression, so removing background noise, unwanted background noise. And that's being done quite successfully today using deep neural networks. Beamforming. So beamforming means if I've got an array of microphones on my device, so if you go and buy a smart speaker today, you'll find either 2 microphones, 4 microphones, or 7 microphones, depending on who made it. And I can use that array of microphones in order to listen from a particular direction and ignore sound from other directions. So that's what beamforming is. Voice activity detection, often I'll need to work out whether there is any speech before I can recognize it. That's what that task is. Reverb suppression, so we'll talk about reverb in a sec. Echo cancellation, so that might also be a slightly unfamiliar term. So let's talk about some of those with examples. So I'm going to play some recordings of people talking to real devices, in fact, me talking to real devices. So let's start with a recording made from a mic like I'm wearing at the moment, and like this guy on the slide is wearing. And it sounds a bit like this.
Recognize speech.
And the same phrase spoken in a real room, picked up with at a decent distance by a decent microphone in a consumer electronics device, sounds more like this.
Recognize speech.
So a couple of things to notice there. Firstly, with the close mic one, I got really nice onsets or plosives that allow me to, really hone in on the starts of words and distinguish exactly what sounds are being made there. Whereas in the real room, I've got background noise going on the whole time, and I've also got reverberation, so the sound's bouncing off all the walls, and you can see the smearing effect that occurs as a result of that, this temporal smearing. So that's of course going to mean that that sounds run into the next sound, and it's going to make it much harder to recognize what speech is being said. But your problems don't end there. In addition to sort of that low-level background noise and your reverberation, often there's actual noise going on. So here's what sounds. Here's a recording from an actual kitchen with the range hood going, the extractor fan going.
Recognize speech.
So that was the one I played you before. This is the one with the extractor fan going.
Recognize speech.
So that's an actual recording of the sorts of things that people have to recognize in real kitchens today. If you're a smart speaker manufacturer, I'll play it again.
Recognize speech.
And one of the things that can help you there is multiple microphones. Now, if you're wearing a stereo headset, you might get an advantage. You might be able to hear the difference here. If you're just listening from a computer, you might not. But if I've got multiple microphones, you can use the direction, the different direction that the sounds are coming from to help you distinguish what's going on. And we humans are very good at doing this, and computers can be made to do it too. So let me play you the stereo version.
Recognize speech.
Oh, sorry, I think I was mono. No, that was the stereo version. Okay, mono.
Recognize speech.
Stereo. No. Try it again.
Recognize speech.
Okay, there's the clean one.
Recognize speech.
Mono.
Recognize speech.
Stereo. I'm not actually convinced that was terribly stereo, but it was still pretty hard, whatever it was. So your woes don't end there, because typically if you're operating in a kitchen while someone's cooking dinner, they also want to be doing things like getting instructions from the virtual assistant on what the next ingredient to put in the soup is, or listening to music while they cook, or even potentially watching MasterChef while they're cooking or something like that. And so now you have the echo problem, and this occurs because in a smart speaker or any other consumer electronics device, the speaker is typically a few centimeters away from the microphone on the same device, and you, the human, are 1 or 2 meters away, and that means that the speaker's own output is coming back in its own microphone much, much more loudly than your own speech. So this is where we were before.
Recognize speech.
This is an actual recording of an actual smart speaker with someone trying to talk to it while it's playing music at a relatively low level.
Recognize speech.
Did you get that, Steve? You heard what was said, right?
I could not hear what was said.
All right, let me do it again.
The music drained out.
So that's the kind of input that you have to deal with in the real world. And so to deal with that, you use an echo canceller. It was one of the technologies you use. So what that does is it uses a reference of the sound that's gone out the speaker recently. It uses an adaptive filter to, on the fly, build a model of the acoustics in the room and try to cancel that that sound out of the microphone, leaving you with only a residual. You can do that to some extent, but it's not a perfect science. You certainly can't get rid of all the echo due to a number of reasons. So there we go. Those are some of the examples of the signal processing that you need to do on the front of your speech analytics system. So what I think is an opportunity to do better in this area, and one of the things we're exploring at Dolby Australia, is cross-disciplinary thinking. So what do I mean by that? Well, typically the signal processing comes from one group of people in one part of the company. Often they've done something like electrical engineering at university. You've got speech recognition and ML type people working in another part of the company on the speech recognizer part, and they might have done something more like computer science or some kind of machine learning based subject, data science, something like this. And typically these people don't really think in each other's terms. So the usual assumption is my signal processing is going to take in a dirty signal and produce a perfectly clean signal, and my speech recognizer is going to work on the perfectly clean signal. And you also see different ways of talking about the same concepts. So I commonly hear signal processing people talk about concepts like leveling and attack decay times and compression and things like this, whereas I'll hear machine learning people talk about Kepstrel mean and variance normalization, talking about it more from a statistical point of view. I think there's benefit from recognizing that many of these concepts are the same and starting to bring them together and join it together and think about it as one problem. And this is one of the key things we're trying to do at Dolby Australia at the moment, is look for ways to think about systems that are jointly signal processing and also speech analytics. The second opportunity I think there is to do better is orchestration. So to understand what I mean by that, let's look at this picture of a living room, and we can play a game of how many microphones are in this living room. So let's start with the obvious ones. Let's imagine I've got a smart speaker there. It's not actually a smart speaker. I couldn't find a picture with a smart speaker when I went looking. When I made this a couple of years ago, I'm sure I could now. Let's imagine that's a smart speaker. So that might have 7 microphones on it. My TV typically will have some microphones on it too these days. They'll have command recognition on them. If I've got a sound bar, I can now go and buy sound bars that have microphones on it that also have virtual assistants integrated. The remote control for my TV will often have a microphone in it. Now, we all carry a smartphone. Your typical smartphone will have 3 microphones. You might have a tablet as well, and that probably got a couple of microphones. I can go on Amazon today and buy a smoke alarm with microphones in it that will be listening for emergency situations and activate the alarm. Amazon, a couple of years ago, famously introduced the world's first Alexa-compatible microwave oven. So you can imagine devices like microwave ovens with microphones in them. I can go in today and buy light bulbs with microphones in it. Now, today they use that just for pulsing the lights on and off in time with the music. But what if you could bring those microphones to play in working out, what's going on in the home better? And lastly, what if things like my couch had microphones in them? You can go and to IKEA today and buy a smart speaker which you can use as a bookshelf that they've developed in collaboration with Sonos. So starting to blur the boundaries between what's furniture and what's an electronic device in this area is an interesting trend. And so today, each of these devices works independently to listen to you. You need to go and address each one independently, and they want to listen independently. So you need to be close to each of them to talk to them. What if they were able to communicate and share information so that they could tell what you were saying? And if they were able to do that, how would you do that without invading people's privacy? So this is another area that we're interested in, is how do you get the good aspects of bringing together multiple microphones to hear you better so that it's more seamless and has less friction without invading people's privacy? What technologies can you bring to bear there? So that's another area of investigation that we're working on. And the last opportunity I wanted to talk about was finding the right amount of domain knowledge. It's often said that with the rise of AI and machine learning, that domain knowledge is dead. And that might be somewhat true, but I'm going to give you an example where it's certainly not all true. So this is an example from a paper called "Is the Secret in the Silence?" It's by John Hansen and his team at UT Dallas. You can go and look this up. I'm using it by permission. And what the team did was that they noticed a paper at Interspeech one year in which the authors had built an Arabic dialect detector. So they'd trained a dialect detector such that if you put a 5-second or 10-second clip of someone saying a sentence in Arabic in, it would tell you which of these 4 dialects of Arabic were being spoken in that 10-second utterance. After reading the paper, the team thought there were a few things that hadn't been controlled for in that paper, and so they went and repeated it and built a copy of the system. And then they did the unusual step of feeding only silence in. Now, the original authors had shown that they were able to detect with 82% accuracy which Arabic dialect was being spoken. And the team at UT Dallas were able to show 83% accuracy by feeding only the silence before the speech into the dialect detector. So clearly this is nonsense. How do I have a dialect detector that detects dialect without any speech? And the answer that was discovered with a bit of analysis was that each of the 4 corpora that represented the 4 dialects that the system had been trained on had been collected by different people in different places using different equipment and had a characteristic frequency response that hadn't been controlled for. And so the team at UT Dallas repeated the experiment, having controlled for the background frequency response, and now showed when they put the speech in that they were getting 80% accuracy in detecting the dialect. But as you'd expect, when they put only the silence before the speech in, so I'm talking about, I've got a 10-second speech recording, which got some silence at the beginning, some speech, and then some silence. They chuck away the speech, only keep the silence at the beginning, but they saw 24.7%, so roughly 25%, which is what you'd expect from a system that was guessing at random from 4 alternatives. So there's an example of you've got to know what to look for to know what to control for in an AI or machine learning based system. So here's how I've come to think about it. If I've got two algorithms, on the left, a classical algorithm that's been hand developed. So this is where a person's been sitting down, they might have been listening to a whole bunch of wave files or something, trying to get rid of a certain artifact or something like that. And on the right-hand side, I've got a machine learning driven algorithm. Let's compare what happens in the development process there. Well, to create a classical signal processing algorithm, what I end up doing is running a bunch of vectors through my candidate algorithm and tweaking it. I'm probably working in MATLAB or Python with NumPy or Octave or Julia or one of these sorts of development environments where I can do a whole bunch of numerical algorithms, and I can try different approaches to filtering, to detecting certain kinds of events. And so I'm hand designing that. So it takes careful design. It takes hard work. You've got to try lots of different things. The first thing you try is not going to be the final thing that goes out the door. So you're going to have experiments. What happens if I do this? And I'll run it on a large benchmarking set, for example, and see what my percentage is. What happens if I try this other thing? What's my relative percentage if I do that? And then lastly, domain knowledge. You need to know what the suite of things you could try is when you've got when you're designing the algorithm yourself. So compare that with the ML-driven, the machine learning-driven algorithm on the right-hand side. Well, isn't it just the case that I train it on a training set and I get whatever that training set teaches it? Well, yes, it is. But where does your training set come from? Well, your training set typically comes from combining data from lots of different places and doing things like data augmentation. And this is where exactly the same four traits come in. This is where you need to apply careful design, hard work, experimentation, and domain knowledge. How do I augment the data? How do I guard against artifacts that come from combining corpora together, like the one we just saw, etc.? So in my mind, we're not absolved from using domain knowledge or hard work or any of these things. We just apply it in a different part of the process when we're working with an AI or machine learning driven algorithm. So there you go. There are a few thoughts on some of the challenges in audio AI and some of the opportunities to do something about it. So where did we end up? Well, today I've got one of these. Where I'd like to end up with is one of these. How do we get that kind of seamless, frictionless user experience? Well, I don't have all the answers, but here are the three opportunities that we're working on towards that. So firstly, working out how do I combine signal processing and speech recognition or speech analytics together? How do I find the opportunities to orchestrate devices and make them cooperate without violating our privacy or compromising our trust? And lastly, how do I find the places where it really matters that I apply my domain knowledge? How do I get the right domain knowledge in the right places? And those were pretty much my thoughts for today. So I'm open to as many questions as we've got time for.
Thanks, Richard. So people can either unmute themselves if they want to ask their questions, or if they prefer to talk or type into the chat, I will ask the question on your behalf. Okay, so we've got our first question. Richard Liu asks, how do you separate background noise from a human's voice when the background noise is louder than the person, or if the person is speaking softly?
Yeah, that's actually really, really difficult. And a few years ago, we didn't have a way to do that. Up until a few years ago, the way you would deal with that problem is you would build statistics over time of what you think was noise, and then you would tell what wasn't noise just because it was louder than the noise. So, if you had a fan or a car running, something, or a washing machine, you would build a spectrogram of that sound. And then when something louder than that popped up, you would go, that's the speech, I need to keep that. But like you say, it's not always the case that the speech is louder than the background noise. And it's not always the case that the background noise is stationary, which means, has the same spectrum over time. And so what's happened over the last few years is that people have started using deep neural networks to separate sound, speech from noise. And the way this typically works is you go and you get a whole corpus of different noise in the world, and you get a whole corpus of speech, and you mix it together, and you tell it, here's a mixed together set of speech and noise. Your target is just the speech. Work out how to produce that. Work out what suppression gains I need to produce in order to remove the noise. So that's the way it's typically done in 2021. Hopefully that answers the question.
Yeah, thanks, Richard.
Yeah, so I forgot to add there, your neural network is part of what it's doing is working out which is recognizing that there's speech in there that it needs to get kept. So it's not just the loudness of it it's using to recognize, that's actually the sound that it's speech as opposed to a car engine starting that it's keying off to keep it.
So, Richard, I have a question. You alluded to some of the technologies that need to be used, both across signal processing and then on the analytic side of things as well. In terms of some of the main programming language, you mentioned MATLAB and Python in particular, and Julia as well. Are there other languages that are being used in the team?
Yeah, C is important. For when you need to run it in real time, we'll often make a C version of something. C++ gets pulled out some of the time as well. But at the moment, I think MATLAB and Python are probably the main ones. Julia to some extent as well. But Python, and in particular PyTorch and NumPy are particularly heavily used at Dolby Australia at the moment.
Right, okay. And in terms of the background of the people who are working on this type of technology, what does that look like in terms of a mix of backgrounds?
Yeah, so we really want to aim for a mix, like you said.
Absolutely.
So traditionally, it's been people coming out of an electrical engineering degree who've studied a lot of specializations into signal processing. But because we're trying to glue together, different components here, we really want people who've come from a diverse array of backgrounds. So I was mentioning there, for example, that some of the things that we deal with in speech recognition touch on, finite state automator, graph stuff, lattices, weighted finite state transducers, things like context-free grammars, which are more the sorts of things you'd learn about in a computer science degree than an electrical engineering degree. So, so we have a mix of people from more from a comp sci background, from an electrical engineering background. We have people who come from some psychoacoustics backgrounds, linguistics, some of those kind of areas as well.
I think you've even got a mechatronics graduate
right.
in your team as well. So yeah, quite a multidisciplinary background in terms of the makeup of your team, I guess, as well. Rani has asked a question. Can you talk more about the roles you see computer scientists primarily taking?
Yeah, well, so apart from what we're doing in our teams, where there's a heap of stuff, which is, I mentioned some of the sorts of tech we get stuck into. There's also large bits of Dolby Australia we're working on things like cloud, and so we're really trying to beef up our workforce in that area. So I guess that's people who know JavaScript, who work on server-side technologies, who work in DevOps, all these sorts of places. In addition to the people who are touching the sort of signal processing, the speech analytics, that kind of area. Have I left anything out there, Steve? I think those are the sort of main things to say.
Yeah, look, I mean, I'll talk a little bit more about this when I'm talking about intern opportunities as well, but we do hire a very broad range of people in the tech space, from electrical engineers, software engineers, computer scientists, mechatronics, physicists. It's very, very broad. A lot of people in the STEM industry, mathematical and algorithmic people as well. We hire a lot of those people, so it is quite broad. And we work from looking at signal processing based software that sits in devices in the area that you're looking at, to mobile apps, to C++ client server network applications, to a lot. Cloud is now a really big part of our business as well, going forward with Dolby.io, our new API developer platform as well. So it's a very broad range of people we hire at Dolby. So, yeah, there's generally something in there for everybody, right?
Absolutely.
I've got a question. Do we have to have some AI background? That's an interesting question. So for your team specifically, Richard, I don't know if you want to answer that.
Um, I would say not necessarily. So we've kind of got a range of, even within my team, I mentioned what we're trying to do is glue together signal processing thinking and
Hmm.
and AI type thinking. So to do that, you can't have all AI people, right? You've got to have a
Yeah.
mix of different thoughts. So as Steve mentioned, we've just had someone join the team who's come out of a mechatronics degree, who came and interned at Dolby and went, hey, wow, this is actually really interesting. I've never done any of this audio stuff before, but that's really interesting. And over the course of the internship, got stuck into some of the echo cancellation challenges and realized it was right in her wheelhouse. So she's part of the team and contributing to this signal processing plus AI work.
Hmm. So yeah, so it's not a prerequisite, certainly not, but certainly in your team in particular, and starting to become more increasingly common in different pockets within Dolby. AI and machine learning and deep learning are starting to become areas that we're starting to do a lot more work in.
Yeah, but certainly not a prerequisite, like you said.
No, absolutely. Yeah, no, 100%. I've got a question for Richard. What kind of unique problems for both input and output do different audio devices present? So microphones, laptops, TV, speakers, etc.
Mm. So laptops are particularly interesting because they're one of the places where you have speakers really, really close to the microphone. So this is I'm talking on a MacBook. I've got a headset plugged in because MacBooks are particularly challenging. They've got literally the microphone that far away from the speaker. And the speakers they put in a lot of consumer electronics devices are maximized to just make as much sound as they can. When you make as much sound as you can, you get distortion, and you don't have a reference for the distortion that's been introduced, which means it's very hard to cancel. So I would say some of the classes of problems are microphone very close to the speaker not linear, so you can, it makes it difficult to model to remove echo. Noise is a big one. Um, uh, Sometimes it's even the device's own noise if it's got a cooling fan or something like that in it, which many laptops have. And then let's see, so, in the TV space, you get issues like someone's connected a soundbar to their TV using HDMI, and I've got microphones in my TV, and now I'm trying to cancel the I'm trying to cancel the sound that the TV is playing out, but actually it doesn't come out of the TV's own speakers. It's got some kind of amount of delay and some kind of extra processing in it provided by the soundbar that I don't have a reference for, which makes it really challenging. So that's why having devices cooperate together, this orchestration idea, we think is really powerful and important to being able to do better, understanding of speech, in your home and those kind of places. I think those are some of the main ones.
Yeah, thanks for that, Richard. I've got another question. Did she pick up the AI knowledge during the internship? I presume we're talking about Yin here as well. So from my understanding, she worked in a different team as an intern, so wasn't working directly on AI before she joined your team on a full-time basis.
Yeah.
Is that right?
So she didn't really pick up that much AI knowledge in the team, and she does have some AI knowledge from university, but she hadn't. What she picked up at Dolby was the audio aspect and the signal processing aspect, and found that actually she could do that, and she had enough skills from her mechatronics degree to be good at that.
Excellent. Okay. I've got a question here from Edwina. As a student, what experiences related to speech analytics could we get involved with? And how would you recommend we learn more about audio AI?
Oh. Well, it's a good question. There are quite a few in, well, An internship at Dolby is one of them, probably.
Yes, I was going to say.
Plug. I'm trying to think what other good things there are. So there are a number of good academic challenges that you can go and read about. So you can go and read about some of the work going on in academia. There's some of the big conferences there are Interspeech and ICASP, and there's a challenge that happens each year called CHIME, CHIME, which is around distributed speech recognition in homes. I haven't actually looked at what's going on in CHIME this year, but that's always really interesting. So there's plenty of good academic stuff you can go and read. Of course, there are plenty of startups out there doing really interesting things in speech analytics, and of course many established companies. So if you've got you might be part of the Google ecosystem or the Amazon ecosystem or the Apple ecosystem at home. So reading about what those things do and seeing where the bounds of how they currently perform is a good way to learn about it. Trying to think if there are other. I mean, there are also quite good YouTube videos around some of this stuff, particularly how AI is used to do machine learning. And there are open source bits of software you can download and try as well. So one of the big speech recognition toolkits you can go and download and play with if you've got a bit of time on your hands. It's kind of complicated. Is called Kaldi, Kaldi. That's one of the big ones, and you can train your own speech recognizer using one of those. There's also things like Pocket Sphinx, which is an older one that you can download and train yourself and get a feel for how the training process goes and what it can and can't do. So I would say if you're interested in having a bit of a play around, some of those resources are interesting.
Yeah, no, that's great. Thank you. And obviously an internship with Dolby is a way to do it. I believe you have intern opportunities in your team coming up for the upcoming summer. Is that correct? I don't know if you want to take this a second just to plug that a little bit whilst you have potentially some interested students on the call.
Absolutely. So yes, we've got a couple of intern opportunities in the team coming up over the summer, like Steve says. And what we typically do is bring people in for around 3 months and give you an opportunity to see what it's like to work in the team, work on a range of different projects, etc. And yeah, we've also got a full-time job we're looking for at the moment, but although that's a little bit more on the experience side.
Mm-hmm. Yeah.
Yeah.
If there's any PhD grads, that might be a potential avenue that they could explore as well in terms of full-time opportunities. Sure.
Yeah, but I will say it's not always the case that we're looking for more experienced people. We often have opportunities for people coming out of undergrad degrees.
Yeah, absolutely, and I'm going to speak a little bit more about that shortly as well. Devinash asked, what programming language do you use at Dolby for a software engineering internship? So, as I mentioned, that's quite broad. I'm going to speak a little bit more about that on some of the main languages we use at Dolby as well. I would say the most common used languages across Dolby are C, C++, Python, and MATLAB if you're doing anything on the signal processing side of things. So they're probably the most common languages, but we use a really broad range of languages. So if you are doing mobile app development, it can be Java or Kotlin or Swift and things like that. If you're doing cloud platform development, it's Node.js and TypeScript and a little bit of Python as well. And then whatever cloud platforms people have any exposure to deploying something on, whether it's AWS or GCP or Azure. So there's a very broad range of languages that get used across Dolby. So I hope that answered your question. Excellent. You're most welcome. Okay. Does anybody have any other questions at this stage? Thanks so much for all the input from everybody, by the way. That's been very useful. Very good
thanks
questions.
for making it interactive.
Yeah, absolutely. Okay, well, look, if we don't have any other questions, and I know there's been a few questions around opportunities at Dolby as well, so it's probably a good moment to segue into my part of the presentation. So bear with me for 1 second. Oh, hang on, I've got another question. Can you guys talk more about what we do day to day in the internship? That's interesting one. I mean, it will vary a little bit from internship to internship as well. But why don't I talk a little bit about the internship opportunities as well, and then maybe Richard, if you have any thoughts about day to day activities as well, maybe you can chip in at the end if that's okay.
Yep, sure.
Excellent. Okay, let me get my presentation. Okay, Richard, can you let me know if you can see that pop up on the screen when you see that?
Yep, that looks good.
Excellent. Wonderful. Thank you, Richard, and I really appreciate you giving the talk today. That was really informative. I learned something today, which is always good as well. Even though I work at Dolby, it's good to get a little bit more technical understanding about that area. So my name is Steve
about
Byrne.
Knight Rider or something else?
Oh, well, look, you always had me a Knight Rider anyway, so I was kind of obsessed with that show. And interesting aside, when I went to Universal Studios when I was a kid, this was like years ago, they actually had a Knight Rider car there that you could sit in, and the talking car would actually speak to you, which was one of the highlights of my life, can I just say, as a child. It was so amazing just to see it in the real world. So I don't think they used a very powerful AI tools to do that. I think it was just a guy with a microphone. But still, when I was like 8, I thought it was amazing. So anyway, let's not go there.
Excellent.
So my name is Steve Byrne. My pronouns are he, him. I'm the recruiting manager for Dolby here in Australia, so I look after all the full-time recruitment and the university recruitment as well. And I wanted to talk to you briefly about our internship program. So that would be Dolby U. So this is our intern program that we've built up. It's been running in Australia for almost 10 years now as well. And what we aim to deliver is some real work experience where you actually get embedded into a team and actually be given some real world work to do. So the idea is that you will grow your skills as an engineer and come out of it stronger at the end, and hopefully you'll have a fun time whilst you do it as well. The work is challenging but achievable, and in order to help you succeed, you're given a mentor who will work with you one-on-one across the duration of your internship. But you'll also get some support from the wider team that you're a part of as well. So we're going to give you a piece of work that you can deliver in the time period, which is generally 3 months. And then you present that back to the business at the end as well, and an opportunity to showcase what you've done. It's a paid internship. I think that's worth saying. I'm not a big believer in unpaid internships as well, so I'm always very dubious when I see them come up. So I want to make sure that you all know that yes, it is paid. When we run our internships is generally over the summer vacation period, so that's end of November through to end of February. I know that UNSW students have moved to a trimester system as well, which makes it a little bit trickier to complete the internship in that time period, given that you've got a constricted summer vacation window. And we will be flexible, and given that we hire more interns from UNSW than any other university in Australia, we want to make sure that students who come from there have the opportunity to take up Dolby internships as well. So, for instance, we've got a number of students who have actually taken trimester 1 off completely to go and do a Dolby internship, and they just started in the last couple of weeks as well. And prior to that, we had some folks who had done it over the traditional summer period as well. So there is flexibility there, and we'll work with you to make sure that you can do an internship and get the most out of it and have a good experience as well. Our office is based in North Sydney. So we've got a facility there with 150 people. Almost everybody is an engineer, bar me and about 10 other people as well. So it's a highly technical office, and we do core research and development work for Dolby as well. We're one of the premier research and development facilities for Dolby globally. And so not only are we working on core work for Dolby, we're also doing some future leaning and leading things in the industry as well. So Richard's team as well, looking at the idea of the future of interconnectivity of devices in the home is a really interesting case in point as well of some of the work that we're doing. We're also leading the Art Cloud Services efforts and Dolby.io development from Sydney as well. So it's great to see that we're trusted with core technology and also brand new areas for Dolby to move into as well. One of the questions I get asked a lot is, given the pandemic, whether or not there was the opportunity to work remotely. We do have flexibility there as well. Most of our interns have been doing a mix of on-site and working from home as well, so that there's a little bit of flexibility in there as well. We want to make sure that people feel safe. I mean, I think we're very lucky in Sydney that we now have 50 days in New South Wales with no new cases in the community as well. So we're certainly, in global terms, very lucky to be able to have the opportunity to go into the office as well. So having that sort of flexibility is really good, I think. Who do we look for? So our internships are open to everybody from first-year undergraduates through to master's and PhD students as well. So the idea is anybody who's still at university has got an opportunity to come in, and if they demonstrate they have the competency to do the role, then we'll give them the opportunity as well. And it's not just about coming in and working. We also have opportunities to give back to the community. We have corporate volunteering that's woven into the curriculum of the internship as well, and opportunities to give back and also to learn something as well. So some educational things and some fun events in there as well. We want you to have a good time whilst you're here at Dolby. So who are we looking for? That was a question that was asked earlier on and asked around some of the programming languages that we use. So here's an example of some of the technologies that we use at Dolby. It's not exhaustive, and it's also, you don't need to have exposure to all of these areas. We don't expect people to be across all of these. So if you have got exposure to one or more of these areas, you're generally somebody that would be interested in talking to at Dolby. So as I mentioned, C, C++, signal processing and MATLAB, exposure to mathematics and algorithm development, cloud computing, which is such a big part of our new business area in Dolby.io as well. We've got a limited electronics team as well. A lot of people think that Dolby makes speakers, but we're about 97% a software company. So, but we do have a team that is doing some electronics work, and we actually do have an electronics-based internship this year as well. Mobile apps, I think I mentioned as well, Android and iOS. And main scripting languages we use are Python, which is used, that's probably the most common language I would think that's used across Dolby. Would you agree with that, Richard? I'd say pretty much.
I think so, yeah.
70% of the engineers would probably be using Python in some capacity reasonably regularly.
Yeah, between C and Python, that'd be the case.
Yeah. Absolutely. And JavaScript, particularly Node.js, is increasingly important to us in our cloud computing efforts as well. And obviously can't go without mentioning machine learning and AI as areas of increasing importance, as Richard has just ably demonstrated with his talk as well. So there's some of the sort of technical skills we look for from interns. But beyond that, we're also interested in people who actually have a genuine love of technology. I mean, at the end of the day, we are a technology company. We are a company that creates and invents and innovates. So, we want people that share that passion as well. If you have an interest in audio or video, that's really nice. And certainly, we've got a very broad mix of different types of personalities here at Dolby, and people who are musicians in their spare time, or sound engineers, or filmmakers, or people who love building electronics. It's quite broad, and it makes it a really interesting place to work. YouTube influencers, absolutely. So yes, we certainly have those. And for me, I love movies. That's one of the reasons why I love working for Dolby. I'm quite selfish, and so I like the idea of working for a company that makes my experience as somebody who watches a lot of movies better. So that's one of the reasons why I like working for it, and it makes it a cool place to work. We also like people who've got hobbies, and maybe who are playing around with technology, building their own stuff. So we've had people who, built a mobile app or a website, or tinkered around with a robot. We had someone who built their own electronic guitar foot pedal as well one time, which I thought was kind of an interesting project to do on the side. We've had people who've come and built speakers. It's very, very broad, and it doesn't have to be anything that's audio or video related. But it's nice to be able to point to some extracurricular stuff that you've done, whether it's project work at a university and you've gone and collaborated with other people, or something you've just gone and played around with in your spare time. That's kind of nice to see. Grades, it's not just about grades. We look at you holistically as a person as well. I mean, obviously, having good grades is certainly helpful when you're applying for internship positions, but it's not. We don't purely just look at grades as well. We want to see you as an individual as holistically as possible as well. And I think the final thing I'd say is that we are an innovation company. We like people who are self-motivated, self-starters, that side of things as well. So people who have that get up and go are generally a good fit for Dolby. Okay, there we go. So how do you apply? So first of all, I just want to point out the variety of roles that we offer this year as well. So this year we're offering, I think, 15 internship positions across these types of positions as well. So C++ software engineers, DSP software engineers and tests. So we do a lot of automation tools development. We build complex tools to help automate the testing of the software, which is very complex software as well. We've got full stack software engineers. I think I mentioned Node.js and Python as languages that we use quite extensively there, and then exposure to any cloud computing is nice to have there. Intern researchers, there's your team, Richard, as well. So you've got a couple of positions available in your team working around DSP and AI and related technologies as well. And then we've got one electronics engineering position as well that we'll be offering this year. So
any other intern positions from the other research groups this year?
Yes, we will do. I'm just getting finalized details on that at the moment, but we will have a couple of other researcher positions as well. So again, on all of these roles, we'll utilize a variety of the different skills I mentioned in the previous slide as well. So if you've got one or more of those and you're interested in Dolby, please submit your application. So you can go to careers.dolby.com and put in Australia as the location tab and intern as the keyword, and it'll have a list of all of our intern opportunities as well. They're not open just yet. We're looking to get our positions open by Wednesday, and then the applications will stay open until Friday, 9th of April of this year as well, and then we'll go through the interview process beyond that as well. So in terms of what we ask for in your application, we'd like you to submit your resume, a copy of your transcripts as well, so we can see what types of units you've been doing. That's useful for us to be able to see what you've done, and also a cover letter. And I want to sort of mention a little bit about that because it's an opportunity where you can actually tell us a little bit more about yourselves, particularly where you may not have a lot of experience on your resume as well. So it's an opportunity to look at the job description, see where you might fit some of the skills that we're asking for, tell us a little bit why you're interested in Dolby and why you're interested in the role, and it just helps to flesh you out, I think, as a candidate as well, and help you stand out as part of the application process. So my advice is to put a little bit of thought into that as well. So that is the main part of my presentation. I just wondered if anybody had any questions that they would like me to answer around that.
I can see there's one here on the chat, Steve.
Excellent.
From Waleed. Does Dolby accept internationals for the graduate?
Oh, good question. Yes, we absolutely do. Yeah, we 100% do. So hang on, I'm just going to stop sharing this so people can see my face. Yes, no, we absolutely do accept international students for interns and for graduates as well. So how graduates can get opportunities with Dolby is you need to apply for a graduate visa. And so once you apply for a graduate visa, that usually gives you an 18-month or 2-year window on a graduate visa. And in that time, we'll hire you until the end of that visa. And if you can get permanent residency, which is pretty straightforward in that time period, you will just keep you on as a full-time employee. So that's the path for international graduates into Dolby. Where would we go about applying for internships? So yeah, just go to careers.dolby.com. As I said, our internship positions open on Wednesday. I'm just going to send a link in the chat as well. If you want to register your details with Dolby, and you can even include a resume if you want, but it just asks you, if you don't want to do that, just your name and your email address. You can register your interest with Dolby, and we'll reach back out to you and let you know more about the intern and graduate opportunities as they open as well. So there is the link. I'll make that available to the CSE Society as well if they want to pass that on to the student base as well. But you can register your details there, or you can just go to careers.dolby.com and put in Australia and put in intern as the keyword, and all our intern opportunities will come up. Waleed, you've asked the question, how do international interns at UNSW work? Yes, that is a very good point. There is a limitation with international students in that during term time, they are restricted to a maximum of 20 hours a week working. So what we've done in the past is we've hired international interns full-time for the 9-week period where they are out of term time, and then when they are in term time, we keep them on part-time, meeting the 20 hours a week maximum to comply with the government regulations there as well. So it means that the internship will last a little bit longer than 3 months, but that's because the student will be doing maybe 2 days a week part-time at the later part of their internship. I hope that answers that. From pure curiosity, is there a reason one of Dolby's premier research facilities is in Australia? Oh, that's an interesting question.
I can have a crack at that if you like.
Please do.
So Dolby does research in lots of places around the world. We have a big research facility in San Francisco, which is where our headquarters is. We have a vision research facility in LA. We have codec research in Stockholm in Sweden. We have some research in Nuremberg in Germany, and we have a big research facility in Beijing in China. And then a big research facility in Sydney. And so we do research in a lot of places around the world. Why is Australia particularly seen as one of the great places to not only research but also development? Well, I think we've developed over time a real can-do attitude, and we've made a lot of things that have gone into successful products out of the Sydney office.
Yeah, I believe we overperform for the size of office that we are output for software and patents for Dolby, if I'm not mistaken. So we punch above our weight. The plucky Aussies do it again. So
yeah, that's true. And we've got access to a lot of really talented people
yes.
in this country is one thing to say. So that's definitely part of it.
Yeah, no, absolutely. And one of the reasons why Dolby is even here in Australia, I think, just to close the loop on that, and I think you alluded to this earlier on, Richard, was Lake Technology. So Lake Technology had a portfolio of codecs, and Dolby acquired Lake Technology in the early 2000s as well. So when we became Dolby Australia, we were still quite small. I think somewhere in the region of about 20 to 30 people. Is that right? I was before my time, but at Dolby, but in and around that sort of ballpark. And so we've grown to about 150 people since then as well. So it's nice to see that it's a growing office.
Yep.
Excellent. Okay. I've got a question. Oh, sorry, someone's asked the question, do you have any idea what an intern would be doing during their internships? And that's a good question, Alex. And I think it was a question that was asked a little bit earlier on in the talk as well. We said we would sort of circle back around to what sort of day-to-day activities are like as an intern. It depends a little bit which team and which role you go into. So in a lot of the teams, they will work in a in an agile environment, and so they'll have Scrum methodology, which means that they will break their work down into maybe 2-week sprints and have daily stand-ups and talk a little bit about the work they've done and the work they've got upcoming as well. And that's how a lot of modern software engineering teams work these days as well. So it's a great way to be able to keep focused on tasks, break them down into smaller, achievable pieces of work, and be able to shift focus if you need to quite quickly as well, and be agile, I guess, as the name suggests. That tends to work in the product engineering environments. Research teams tend to be a little bit different. I wonder, Richard, if you might talk a little bit more about that.
Yeah, well, we tend to be more about, because the job of being a researcher is more about asking questions. So I characterize it as we want people who inherently ask the right questions and then work to answer those questions definitively. Questions that are really going to help us move forward in our business. So it's not about producing code as much as about answering questions. So what we tend to do is meet regularly to ask what questions have been asked this week and what answers you've got. It tends to be the way the collaboration happens. Some of those times, sometimes it's multiple people working together to answer a question. And other times it's people working sort of individually to go and answer a question and then present it back to the rest of the group.
Mm-hmm. Yeah, so there's just slightly different ways of working, I think, aren't they? And depending on what outcome you're looking to get, I guess, as well. So, yeah, there's different ways of working. But certainly for all of the intern positions, you will be focused on something practical and something real world that gets used by Dolby, whether it's something we use internally. So sometimes interns work on a tool or some sort of analysis software that might be helping in a particular area on one of the teams, or they might actually be working on something that becomes part of a product that goes out externally as well. So whichever way it is, it's a really good experience to get as an intern, and certainly we hope it would make you more employable in the general populace when you graduate, I guess, as well. Dolby's a good name to have on your resume. One thing I'd like to mention here is that obviously intern roles are seen as a pathway into full-time employment for Dolby as well, and we've got a dedicated graduate program where people who've been interns can go and work at Dolby on a full-time basis as well. We also hire graduates externally as well, so you don't have to be an intern to be a graduate at Dolby, but certainly it is one of the pathways to come into Dolby as well, and we've got a really good track record of converting interns into full-time employees as well. So long may that continue. Okay, I hope that answered that question. Waleed has a question. As a first year who might not have had the time to get their first internships or such, what would you suggest as things that can help make up for that? Do projects, leadership roles in society, CSE, society, etc., and tutoring help in that aspect? Or showcasing technical ability and collaborative ability? Yeah, look, they're all very good suggestions actually for people who are right at the beginning of their internships as well. And look, the reality is it can be difficult as an early career student to get internship opportunities where you might be up against students who maybe have, a couple more years experience than you in that as well. But ultimately, certainly at Dolby, we take everybody on their merit, I guess, as well. So it's an opportunity to come in and learn, as well as an opportunity to come in and demonstrate what your capabilities are as well. So we'll take that into consideration. But certainly, anything you can do to make yourself stand out. So whether it's as I mentioned, doing some stuff in your spare time. And I know that can be hard when you've got other commitments at uni, so it's not always possible. If you have any involvement in society, so CSE society, etc., or sporting activities that you do, these are all things that are interesting. Any volunteering work that you do.
Or if you've got a GitHub,
Yes.
where you've been putting some of your own projects up, that's interesting as well.
Yeah.
I'd love to hear about the 3D printer you've been building at home, or the guitar pedal, or the electric bicycle, or whatever it is.
Yeah,
Love to hear
yeah,
about those things too.
yeah. And look, there are things that hiring managers are keen to find. If you mention that in your resume or in your cover letter, that makes you interesting. It gives people, it's an area to talk about a little bit more in an interview, for instance, as well. And you know, if you start talking about something that you've done that you're passionate about and you enjoy, that really comes through to interviewers as well. So it certainly helps on that front. So I hope that answers that. Yeah, but don't let it stop you from applying. I absolutely wouldn't I say that you know, sometimes first years or second years might feel that, oh, I can apply for positions, and I know some organizations will only hire penultimate year students, but that's not the case at Dolby. We'll take everybody on their merits. So if you're interested in opportunities, you know, put your hand up and apply. You won't lose out by doing it, and you're starting a relationship with Dolby, even if you don't end up getting an internship first time around. Excellent. Okay. Any other questions? I think we're coming towards the end of the time we have. I've got a question. Okay, do you mind sending a copy of the slides to CSESoc so we can distribute it to the students? I'm going to send a video recording of this presentation of this talk to CSE Society, so you'll be able to access it from CSE Society there as well. So hopefully that will give you access to all the information that you need. So I hope that answers that question. Also, is each application assessed individually? So if you aren't good enough for first year, it won't hurt your chances in second year. No, absolutely, absolutely. So, and if you think about it in those terms, if you miss out the first time, and sometimes you do, and we unfortunately we have more really interesting and talented students that we have to say no to because we've got limited places in our internship program as well. You know, it certainly won't hurt your chances if you come back to us the next year. In fact, it shows us that you're really interested in Dolby, so that's a good thing. We don't think that it's a bad thing, but we'll assess your application individually as well, so each time around. Although, you know, as I said, it's if you have a prior relationship with us from the previous year, that's a good thing, I would say. Rani also asked, does Dolby also hire throughout the year besides the intern and graduate programs? Yes, so we have full-time positions available all year round as well. So we tend to have one intern intake period, which is generally this time period. So March and April is when we look to collect resumes, and then we go through the interview process from there as well. So that's a one intake period. But in terms of full-time opportunities, we're hiring all year round. Just go to careers.dolby.com. It's got a list of all our open positions as well. It's interesting to see the different types of positions that we have available as well. You'll see it's, as we've alluded to, it's very broad. It's very broad. So I would hope that there would be something in there for most of the people who would be in CSE Society. I'm sure there's a position there that might be of interest. For students, we tend not to have, our main hiring of students tends to be through the intern program. So on occasion, we will have some casual or part-time work available. Although I would say that we usually will go to our intern cohort as a first place for those people to take those positions, just because they already know Dolby, they're already a known quality to Dolby, and so that sort of acclimatization period has already kind of taken place, and so they can come in and hit the ground running if they're doing some casual work as well. But it does happen on occasion as well, but I would say it's the exception rather than the rule, in all honesty. All right. Any final questions? I think we've got about 4 minutes left. I think we've exhausted all the questions. Excellent. Well, thank you all so much for joining us this afternoon. Really appreciated the talk by Richard, so thank you so much for that, Richard. I really enjoyed that, and I really enjoyed speaking to you all this afternoon about intern and graduate opportunities. I hope to hear from you all, so please reach out. I will also send my email address in the chat as well. If anybody wants to reach out to me to talk through opportunities, they absolutely can do that. And beyond that, if you're interested in Dolby, either apply directly to intern opportunities, or if you click on the link I put into the chat, you will be able to register your details with Dolby, and either myself or one of my colleagues will follow up with you, and we can talk to you about further opportunities with Dolby. So look forward to hearing you all.
Thank you for having us.
Yeah, thank you. Have a good afternoon, everybody.